Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about simplifying exponents. I've got an example right here, and this is sometimes called a monomial because there's no plus or minus signs in it. This is one big term. And we're going to talk today in our video about how to simplify these, and we're going to jump in right now. Let's get in it. If you have not watched the previous video about the basic rules of exponent simplification, you're going to have a really hard time with this one today, so I'd recommend that you watch it there, link in the description. Whenever you're doing a problem like this, I would recommend, particularly when you're starting out, is to write out exactly what each of these things means. X squared, again, that's not x times 2 or something. What that means is that there's 2 x's multiplied together. This means there's 3 y's multiplied together. So what I really encourage you to do in this problem is write them out before you do anything else. Okay, so this is x times x. And over here, we've got y times y times y. A couple of quick things about variables. Remember, I can't put variables together that are different. I can simplify x's that are the same, I can simplify y's that are the same, but x times y doesn't make like z or something. You can't put them together and combine them. So you have to leave them separate. Okay, we're going to do the same thing on the bottom here. I'm going to change x to the 5th to 5 x's times or multiplied together, and y to the 2nd power is just 2 y's multiplied together. Like a little random tail there. Okay. So there's what I've got. I've simplified everything. If you remember from the last video, we looked for big ones. We tried to find things that canceled out because anything divided by itself is just 1. So I can go ahead and see some 1's right away. I see there's a couple of these y's that will divide out. Y divided by y is 1. Y divided by y is still 1. Okay, so I have 1 times 1 there. Those canceled out. And the x's, you're going to find the same thing. I've got 2 of the x's that cancel out. X's on the top, x's on the bottom. Those both cancel out as well. So let's see what I'm left with after I've done all of this crossing off. This is, a lot of people love doing this. They just get kind of crazy and start crossing stuff off. I encourage you to be particularly aggressive when you cross things off. It's cathartic. It takes the stress out of math because you get to, you can hurt math back when you cross stuff off. Okay, so that leaves me, if I think about this as a big division problem, there's only one thing left over on the top. Y. And on the x, I've got 3 x's on the bottom. And instead of writing that as x times x times x, I'm going to re-simplify that into x to the 3rd power. So that whole thing simplifies here. And again, you could think about this as with our shortcuts too, if you like. So we had x squared and y to the 3rd over x to the 5th and y squared. And with this, you say, all right, well, I remember with division, I'm actually subtracting. It's because I've got all these x's and 2 of them are going to cancel out, and that leaves me with 3 on the bottom. And with the y's, when I cancel these out, 2 of them are going to cancel out, and there's going to be 1 left on the top. If you like, you can leave this as y to the 1st power. That's not wrong if you put that in. It's not wrong if you don't. It's just another example of a ninja 1. All right, that was a pretty easy one. Let's try another example. All right, let's see what we got here. This one looks kind of intense, and the additional problem here is there's some numbers thrown in. Teachers love to throw some numbers in there, and when you're dealing with numbers, you treat them like their own group of variables. So when I'm looking here, I see that I've got some x's, I've got some y's, but I've also got some numbers. Okay? When you are doing these problems, I want you to think about them as separate groups. You can combine x's with other x's, you can combine y's with other y's, and you can combine numbers with other numbers. So think about the numbers as their own group. A lot of times I like to start with those and get them out of the way so I don't get mixed up. Okay, so I'm going to see here, this is all multiplied together. When you're multiplying things together, it doesn't matter the order that you multiply them in. For example, 2 times 3 times 4, if you type that in your calculator, it's 24. If you do 4 times 2 times 3, you still get 24. It doesn't matter what order you multiply things in. You can multiply the 2 and the 4 together and then the 3, or the 3 and the 4 together and then multiply the 2, or the 2 and the 3 and then the 4. It doesn't make any difference. Multiply however you want. The order doesn't matter, and the order doesn't matter even if there's variables. So what I'm going to do here is I'm going to pick the variables that are the same, the numbers that are the same, the x's that are and the y's that are the same. Okay, so first I'm going to choose to multiply the 2 and the 6 together. Those are going to be, if I multiply them, 12. And I would encourage you, when you have a big thing like this, once you've completed an operation like multiplication or division, cross off the things that you're done with. That way you remember that you've covered everything and you don't do anything twice. Now I'm going to do the x's. X to the third and x squared. Remember, x to the third is just 3x's. X squared is just 2x's, so that's 3 and 2. That's 5 total x's. So I'm going to go ahead and write x to the fifth. And I'm going to go ahead and cross those off too because I'm done with those. And then lastly, I've got my y's, and I see here I've got 4 y's and 2 y's. So together that's a total of 6 y's that have been multiplied together, which I can abbreviate as y to the 6th power. And that's as simple as you can get it. You can't do anything else. Remember, the exponent only refers to what we're talking about here. By the way, just as a quick vocab note, this is known as the base. The thing that has an exponent on it is called the base. There you go. Bonus vocab for you. Let's see if we can get even tougher. Okay, now we got a bunch of stuff put together here. And we're getting more and more complicated. Remember, when you are seeing exponents that have a power on them, if you see parentheses and a power, I want you to work from the outside in. So this 4, again, doesn't distribute. What it's saying is this entire thing is being multiplied by itself 4 times. I want you to write that out. It takes an extra 4 seconds or something to do that, but it's going to keep you from making a lot of errors. Okay? So what I've got here is this is 2 times x to the third times y to the 6th. And I'm going to write this whole thing, because that's what's to the 4th power, I'm going to write that 4 times. Now again, some of you might feel like this is tedious, but it'll be a lot less tedious than having to retake the class because you got it wrong, okay, on the final. Just take your extra time, and once you get good at this, once you've done a couple of worksheets with this, then you can start thinking about it in your head and you can do that shortcut. But when you're starting, please write them out. It's really going to help you develop that intuition, okay? Now I've got all these things together and I'm going to combine them just like I did last time. I'm going to combine my numbers, I'm going to combine my variables, and put the variables that are the same together. And I see here, I'm going to start with my numbers. I've got 4 2's. That's 2 times itself 4 times. Now you can multiply that out if you want to, or you can just leave it as 2 to the 4th power. Which is kind of nice. 2 to the 4th power is 16 if you want to write it that way. Next thing I've got is I've got a bunch of x's. Now remember, I want you to imagine these are all multiplied out. X to the third, that means, oh, by the way, I'm going to cross these out because I'm done with them. Okay? I've got x to the third, that's x times x times x, that's 3 x's. 3 more x's is 6 x's. 9 x's, 12 x's together. And then lastly, I've got my 6's, and there's a huge bunch of those. I'm going to cross the x's out now. 6 y's, 12 y's, 18 y's, 24 y's. And there you go. And that would be an answer. Again, most teachers are totally fine with you leaving a number to an exponent. Particularly sometimes you're going to get some really big numbers there, and it's just easier to write it like that. Well, if you're still with me, we're going to keep doing a couple harder ones. Now I'm being real mean. I'm going to throw negative exponents at you, but I think you can handle it. Again, if you haven't watched that previous video about exponent properties, I'd recommend that you do that because we're going to use a nice shortcut here. Y to the negative 4th power. Remember, that's division. Y divided by itself 4 times. This is the same thing as 1 over y to the 4th. Now, you can break this up as much as you want, but I want you to notice something here. This is at the bottom of a fraction. This is at the bottom of the fraction. Okay? And here's the rule of thumb. Negative exponents on the top, they go to the bottom. So I can actually rewrite this by thinking about this y to the negative fourth going to the bottom of the fraction, because that's what it means. It's divided by itself 4 times. So what I'm left here with is a fraction, y squared, and then I've put another y to the fourth here. If you want to know how to connect those, it's with multiplication. It's never going to be addition or subtraction. Always put that multiplication sign in there if you're not sure. And then the question is, what's on the top of the fraction? There's that 1. Remember, that 1 is still there. This is going to be my new problem. So I have y to the second times y to the fourth. Just because that's on the bottom of a fraction doesn't change the process. That's 2 y's and 4 y's. That makes 6 y's. So this whole thing is going to equal y, or 1 over y to the 6th. Okay, and again, the rule of thumb here is that negative exponents on the top, you just can put them on the bottom of the fraction, but don't forget there's a 1 up there, really important. A lot of people forget that 1. Now, this is a trickier problem because you may notice there's a negative exponent on the bottom. So what on earth does that mean? Well, let's see what we can figure out here. We can just take this on its own. Let's break that up into its own little mini problem over here. That's 1 over, again, we can just imagine there's a 1 here. We're just going to just pretend nothing else is there. Just look at this, over y to the negative fourth. But remember, something to a negative power is divided, so what this really means is 1 over y to the negative fourth, or y to the positive fourth. Holy buckets, that looks horrible. Fractions inside of fractions, what is this, Inception, but with math and not fun? By the way, Inception is probably my favorite movie, just throwing that out there. Okay, if you haven't watched it, you should watch it, it's fantastic. This is a division problem, try not to get freaked out. I've got 1 divided by 1 over y to the fourth, so that's 1 divided by 1 over y to the fourth. This looks a little bit more familiar because we know how to divide fractions from 4th grade. We talked about this in previous videos, but you multiply by the reciprocal, or if you like better, you copy dot flop. Copy the first fraction, change this to a dot, and I flop the second fraction. So this really becomes 1 over 1 times y to the fourth over 1. And when you multiply fractions, that's super easy. Straight across, 1 times y to the fourth is y to the fourth. 1 times 1 is 1. So here's the crazy thing. 1 over negative exponent, that whole expression kind of seems to move to the top of my fraction. And here's the great news. That's always going to be the case. You don't have to do the actual division of fractions. You just need to remember the shortcut. If you have a negative exponent on the bottom, you just move it to the top and it becomes positive. So when I see this y to the negative fourth here, all I need to do is take that and move it up to the top and it becomes positive. And now I can do the rest of this problem pretty quickly. Y to the third and y to the fourth, what does that make? That makes, there's 3 y's and 4 y's, that's 7 y's. So I get y to the 7th on the top. X squared and x to the fourth, that's 2 x's on the top, that's 4 on the bottom. How many cancel out? Well, 2 of them do. Leaving you with 2 left over on the bottom. Okay, so you can do these problems. If you remember, negative exponents on the top, they go to the bottom. Negative exponents on the bottom, go to the top. And that's about as complicated as you need to make it. All right, I'm gonna try one bonus question. I'm gonna see if you can do it. I'm gonna put all of this stuff together in one terrible, horrible problem. If you can do this one, you can do anything that your teachers can throw at you. Good luck. All right, I want you to pause right now if you haven't been already. See if you can get this on your own. Remember all the little rules. If you take your time and write stuff out, you can do anything, no matter how complicated it is. We'll be very careful of not jumping in too far into these shortcuts though. All right, I'm gonna show you the result and how you do it. See if you got it right. Here's the trick that I'll show you to save you a little time if you want to. If you have a big thing like this, you can simplify it first and then do the exponent. And that's what I'm going to do here. Instead of doing everything twice, I'm going to simplify it and then do everything twice. It's going to save me a little work. I'm going to start with my numbers. 2 over 4. That's a fraction. It simplifies to 1/2. So I'm just going to rewrite that. X to the third, that's a negative exponent on the top. I'm going to put it on the bottom. So that becomes x to the third on the bottom. Y to the fourth divided by y to the second. That's 4 y's on the top, 2 on the bottom. That means 2 are going to cancel out, and the ones that are left over are on the top. So that gives me y squared on the top. Almost done with the simplification. I just have to do x to the third times x squared. Again, I'm just multiplying. Who cares if it's on the top or the bottom, so long as everything's positive. That's 5 total x's. So I got x to the fifth. And this whole thing is squared, which means I'm going to write the whole thing twice. So I have 1/2, and then y to the second, x to the fifth, times another one. Now I can simplify that the rest of the way. Y squared and y squared, there's 2 on each, which gives me a total of 4 y's. 1 times 1 is still 1. 2 times 2 is 4. X to the fifth times x to the fifth, that's 10 total x's that are multiplied together. So I can abbreviate that as 10x to the 10th power. And that is your perfect answer. Great job, everybody. Thanks for sticking with me. I hope this has been really helpful for you. And stay tuned. Next video in this series is going to all be about graphing and how we apply this to a coordinate system. So please leave in any comments that you have in the comments, right? It's a good place for them. I'll see you guys next time.